Bismillah Rahman Rahim. Welcome to my channel Learn Math with Sayyid Ali. So continuing our topic Introduction to Integration part 2, right? So we were dealing with like definitions of differentiation and then integration, and then we solve one function was given, and then we solve dy by dx, and then we integrated to get back that function, and we got this concept of the constant of integration. So now the rules, the part 2 deals with the rules, how we integrate this. So all integration of the sort of a to the x to the power n, right, like this 3x square. 3 is a, like constant, and x is the variable of integration. So x to the power n, any power, right, and dx, right? So if we want to integrate any sort of constant x to the power, right, 3x square, 5x square, whatever it may be, the integration formula is a, right, x to the power n plus 1. X, we have to increase one power, divide by the increased power n plus 1. That's what we did here. So I was telling you that 3 is same like this, a, increase one power, so this is 3, and then divided by the increased power, which is 3. So this is the formula of integration of all of these expressions, all of these functions. But if it's only the integration of a constant, that is a is a constant, right, like this 4 dx, right, 4 dx. So what is the integration of 4 dx? This is ax, right? So we introduce x here because we have to increase one power of the coefficient, so we introduce the coefficient. So integration of constant is ax. What happened is derivative cancels with integration, and that's what the definition is, that they are the inverse function of each other. So what we are left with is ax. Hope you understand this, right? So now we take another example which I was supposed to do in lecture 1, but that will be a long video, and long video is hard to understand, right? So hope that you understood part 1, and now we will take another example here and apply these rules which we learned a minute ago, right? So let's take another example. For example, so my dy by dx is given, right? Derivative is given, right, is equals to 4x cube plus 6x square minus 2x plus 5. So this is the derivative given, right? And question would be, what is y? What is y? What is y means the original function, right? If we remove this dy by dx, how can we remove this dy by dx? By integrating. What is left? If the integration cancels, because it is the inverse function of dy by dx, as here, right? So dy by dx cancels with integration and left with original function y, right? So what is y? Sometimes it's what is y, right? What is y means we have to integrate. So y is equals to integration elongated as, put the bracket because more than one term, 4x cube plus 6x square minus 2x plus 5, bracket close, and dx, right, and dx. So this was my literature, right, definitions and other things which you need to remember. So now we have dx. Now what is the rule? So rule is keep this a, right, a is here, so a, 4 is here, increase the one power, so 3 plus 1 is 4, divided by the increased power, which is 4, plus 6, increase one power of variable and divided by the increased power, right, minus 2, increase one power and divide by the increased power, plus 5, the constant is ax, so plus 5x. So this is what we get, and what we have to introduce another thing is a constant of integration for this, because this may be anything, right? And we know that, we learned that if anything is added here, then derivative of a constant is 0. So we have to add a constant of integration. So y is equals to, now we can simplify this, 4 cancels, x power 4 plus 3 to the 6, 2x cube, 2 to cancel, minus x square, plus 5x, plus c. So this is my answer, back to the original function. If I take the derivative of this, I will get this, right? So integration is a process in which we find out an original function whose rate of change is given, whose derivative is given. So this is how we learn, and what we learn is the basic, right? What is the basic definition, right? Differentiation, inverse of a differentiation is called integration. Inverse, so I write it somewhere, inverse, okay, inverse of differentiation is integration. Inverse, right? I will rewrite it. So this is biliary. Inverse of differentiation is integration. This is simple definition, and we know the rule of this sort, but we will do more integration of the trigonometric functions, more complex functions. But if you know this basic, you can solve any question. So you have to remember the differentiation of a constant is 0. Therefore, whenever there is a constant in the differentiation dy by dx, we have to have one constant of integration, right? Which sometimes we denote it by c, and sometimes we indicate it by k, right? So this is the rule. What is the rule? Add 1 to the power, and divided by the increased power. So it's here, add 1 to the power and divided by the increased power, right? And what is that constant of what is the integration of a constant number? So integration cancels with the differentiation or derivative sign, so it becomes ax, right? So all is here differentiation. And in the meantime, what I said in the first lecture, that integral is the function that defines the area under a curve for any given interval. So what does it mean? It means, let me take another pen. So it means that if you have to draw a function between d and t, so it gives you this, right? This area under the curve, this area, right? So integral is the function that defines the area under a curve for any given interval, This is my interval. So in this interval, area of the under this curve is integral, right? So integral is the function that defines the area under a curve for any given interval, right? So this is how we define differentiation. Means breaking something into really small parts. And what is integration? Is a process in which we find out the original function whose rate of change is given. Rate of change, right? This is your t, this is your t, this is your d, right? In this function, in this graph, if it is d over t, that will be delta d, right? Delta d over delta t, right? In this interval, what is that, right? In this time interval, so the curve under the given interval of time. So that is how we calculate differentiation, and the inverse process of differentiation is called integration. And we have the rule. So follow the rule and take some more examples, do the math, and you will be having a third lecture for more complex derivatives and trigonometric derivatives. So we will do it in class 3, right? Hope you like the video. If you like it, press the bell icon button, subscribe my channel, thumbs up, and share it to your friends who may be looking for these videos to learn what integration is. Thank you for watching.